sklearn, linear model, linear regression. Description. Linear regression is a statistical method used to model the relationship between a dependent variable, the target, and one or more independent variables, the features. It aims to find the best fitting linear relationship, represented by a straight line or a hyperplane in higher dimensions, that minimizes the difference between the predicted and actual target values. Inputs. X, a 2D array-like structure representing the independent variable's features. Each row corresponds to a data point, and each column corresponds to a feature. Y, a 1D array-like structure representing the dependent variable target. It has the same number of elements as the rows in X, with each element corresponding to the target value for a specific data point. Outputs. Core, a 1D array containing the coefficients of the linear model. Each element represents the coefficient for a corresponding feature in X. Intercept, a scalar value representing the intercept of the linear model. Steps. Model initialization. An instance of the linear regression class is created, potentially with specified parameters. Model training. The fit method is called with X and Y to train the model. It calculates the optimal coefficient score and intercept that minimize the difference between predicted and actual target values. Prediction. The predict method takes new data, new X values, and uses the learned coefficients and intercept to generate predictions for the target variable. Metrics. Mean squared error. MSE measures the average squared difference between predicted and actual target values. Root. Mean squared error. RMSE, the square root of MSE, providing a measure of the average error in the same units as the target variable. R squared represents the proportion of variance in the target variable that is explained by the linear model. A higher R squared value indicates a better fit. Visualization plots. Scatter plot with regression line visualizes the relationship between a specific feature and the target variable, with the fitted linear line overlaid. Residual plot shows the difference between predicted and actual target values, helping to assess the model's assumptions and identify potential issues. Fine-tune parameters. Fit intercept Boolean, indicating whether to calculate the intercept true or assume it is 0 false. Default is true. Normalize Boolean, indicating whether to normalize the features true or not false. Default is false. Copix Boolean, indicating whether to copy the input data true or modify it in place false. Default is true. Njobs integer, specifying the number of jobs to run in parallel for faster computation. Default is none, meaning it uses all available cause. Uncertainty methods. Confidence intervals provide a range of plausible values for the target variable based on the model's uncertainty. Prediction intervals account for both model uncertainty and randomness in the data, providing a wider range than confidence intervals. Challenges and fixes. Challenge 1. Multicollinearity. When independent variables are highly correlated, it can lead to unstable coefficient estimates and make it difficult to interpret the model's results. Sample use case that resulted in Challenge 1 using features like age and years of experience, which are likely to be highly correlated. Fixes to Challenge 1. Feature selection. Select only one of the highly correlated features or combine them into a single feature. Regularization techniques like ridge regression or lasso regression can penalize large coefficients, reducing the influence of multicollinearity. Challenge 2. Outliers. Extreme data points can significantly influence the fitted model, leading to inaccurate predictions and misleading interpretations. Sample use case that resulted in Challenge 2. A data point with an unusually high target value or an outlier in a feature that strongly affects the target variable. Fixes to challenge 2. Outlier detection. Identify and remove or transform outliers using methods like Z-score or IQR. Robust regression. Use robust methods that are less sensitive to outliers, such as Thales-Chain regression or RANSAC. Challenge 3. Nonlinear relationships. If the relationship between features and the target is not linear, linear regression may not be the best choice. Sample use case that resulted in challenge 3. A relationship between features and the target that resembles a curve or a more complex pattern. Fixes to challenge 3. Nonlinear transformation. Apply transformations to the features, such as polynomial features or logarithmic transformations, to capture nonlinear relationships. Nonlinear models. Consider using nonlinear models, such as decision trees, random forests, or support vector machines, which are better suited for capturing complex patterns. Challenge 4. Insufficient data. Having too little data can lead to overfitting, where the model learns the training data too well and performs poorly on unseen data. Sample use case that resulted in challenge 4. A limited number of data points available for training, particularly relative to the number of features. Fixes to challenge 4. Data augmentation. Generate synthetic data points to increase the training dataset. Regularization. Use regularization techniques to prevent overfitting by penalizing complex models. Feature selection. Select the most relevant features to reduce the number of parameters the model needs to learn. Challenge 5. Missing values. Missing values in the data can disrupt the model's training and lead to biased results. Sample use case that resulted in challenge 5. Data points with missing values for certain features, potentially due to data entry errors or incomplete data collection. Fixes to challenge 5. Imputation. Fill in missing values using techniques like mean imputation, median imputation, or more sophisticated methods like KNN imputation. Dropping rows or columns. Remove rows or columns containing missing values if they represent a small proportion of the data. Feature engineering. Create new features that capture the information present in the missing values, such as indicator variables,